So continuing further, in this video, I will explain the computation of longest common subsequence using the idea explained in the previous two videos. This is string A and this is the string B. And if you look at the contents of string A and B, there are certain characters available here. String A has certain characters. Total length of string A is 7, as well as total length of string B is also 7. So we have created a matrix which is of size 0 to 7 and 0 to 7. Okay, first thing. Second is we have written the string A and B. String A is written on the row side and string B is written on the column side. So if you look at row side, we are writing G, D, V, E, G, T, A. And similarly on the column side, we are writing G, V, C, E, K, S, T. So as I told you in the previous video, there are three different directions. One is U, one is S, and one is D. U stands for up, S stands for side, and D stands for diagonal. And we have another direction which represents H, that is represented by, or which will indicate the halt condition. So if we start with the zeroth character of A and zeroth character of B, there is no content in A also and no content in B also. Hence we can write here 0 and the direction here will be H. This 0 indicates that is there is nothing in A and nothing in B, and hence we can write 0. Now continuing further, if we take nothing in A and there is everything in B, this will also will not generate any output. Okay, and since there is no output, this will represent 0 by H, 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 and 0 by H, because A does not have any string or any character. On the same lines, if you take the reverse case that A has certain characters and B does not have any character, then also we will write 0 by H here, 0 by H here, 0 by H here, and so on. This is just because there is no character in B. The computation starts when there are characters in A and characters in B. Okay. So this is how the first computation goes. Here the character from string A is G and character from string B is also G. And since there is a match, G and G is match, we will use the diagonal value which is 0 and we'll add 1 to this, that is 0 plus 1 is 1, and we will write this as D just because we have referred the value at diagonal position. Why? Because the characters are same. Now if we continue further, the character in A remains same, but character in B changes. That is, character in A and character in B is not same. In that case, we will be referring the upper cell or the diagonal cell. And if I take the upper cell and the diagonal cell, then to look at this idea, upper cell and diagonal cell, then you can see that the upper cell and the side cell, not diagonal. So you can see that this 0 is the upper value and this 1 is the side value. And since 1 is greater, we'll write 1 by S. In the same way, again, if we are taking G and if we compare it with C, we will have to take the upper and the side, and whichever is greater will be written along with the direction. So in this way, we will write, since there is no G further, we'll write everywhere 1 by S. Now, if we continue further like this, then there is next character coming through A is D, and there is no D in the string B here. So we will take the help of upper and side, and whichever is greater, we will write. So now if you look at the position at this point, We will refer 1 by S, will refer 1 by U. Both are same. So since both are same, the preferred direction is U. And in this way, we will write 1 by U everywhere. Now moving further, if I take a character V here, okay, and character G, and if I compare them, so then since they are not same, I'll take the reference of upper and side, and since the upper is greater, I'll write 1. Second step, V and V is compared, both are same, take the reference of diagonal and add 1. V and C not same, take the reference of upper and side and find the maximum and write the reference. So side is maximum. So we'll write 2 by S, 2 by S, 2 by S, 2 by S, and 2 by S. Next, take E. So right now, if you take E and compare G, there is no similarity. So we'll take the reference of upper cell and side cell. And since upper cell is greater, we'll write 1 by U. Now, again, E and V is compared, both are not same. Take the reference of upper cell and side cell. And since the upper cell is greater, we'll write 2 by U. Similar will be, we'll write 2 by what here? Again, 2 by U, because both are same. So we'll take always, the idea is to refer the upper value so that you can reach to the halt state as early as possible. Now the computation comes here. Both are same. So since both are same, take the reference of diagonal and add 1. And in this way, the computation continues. If I give you the idea of this particular row, then here T is not there in the character in the string B. So this will take the help of all the upper cells, but since T is here, it will take the help of diagonal and add 1 to this and make it as 4B. Now your matrix gets completed in this way, and we'll try to find where is the longest common subsequence. So for this, you start with the last cell, which is having value 4. So this 4 represents length of LCS. Now, what is this direction? This direction is U. As long as you're not getting D, you do not get any common content. So once you get D, you will get a common content. So now if you say go up from this cell U, it will give you the first character which is match, that is T. Diagonal allows you to go in the diagonal side. Okay. So diagonal allows you to go in the diagonal side. Up allows you to go to up side. You can refer the dark black arrow here. Side allows you to go side, again side. Now again you get D. Find the character, that is E. So we'll write E. Again check, go side, go diagonal, go side. Again you will get D. Diagonal, go up, again D. And diagonal will let you to go to H. So here your processing stops, and whatever characters which are at the location D will be treated as common characters in the subsequence. Hope you understood this idea in the 3 videos, and you will be able to solve some examples on this. Thank you.